All right, let's go ahead and use this idea of chemical formulas and apply it to moles. Last class period, we learned about ionic and covalent compounds, and we learned how to name them and come up with their formulas. And now what we're going to do is we're going to take these chemical formulas and apply them to the concept of moles. And so a chemical formula shows the kinds of elements and the number of atoms or moles of each element in the smallest ratio possible. So for example, water is H2O. It's a 2-to-1 ratio, and we can think about that in terms of there being 2 hydrogens and 1 oxygen, but also 2 moles of hydrogen and 1 mole of oxygen. Now, the smallest representative unit for a covalent compound is a molecule, and we talked about that. So we call covalent compounds molecules, and it's just one single unit. For ionic compounds, though, we call them formula units. So if we had one single, let's say sodium chloride, that is a formula unit of sodium chloride. Again, next unit we get more into that. The point here is that ionic compounds we call formula units, covalent compounds we call molecules. Mathematically, we treat them the same. So we treat them the same mathematically. So we'll learn more about those next class, our next unit. So a subscript that follows a symbol of an element will tell you the number of atoms or moles of that element. And so, for example, H2O, the subscript 2 tells us we have 2 hydrogens. It's kind of nothing new here. Here is something that's new though. A coefficient that comes in front of the entire chemical formula will tell you the number of molecules, formula units, and moles. And so we'll go ahead and look at an example of that in a moment, but essentially if we had water, which is H2O, and let's say that we put a 3 in front of the H2O, that means that we have 3 H2Os. And again, it's a coefficient, it's the number that goes in front of the molecule, and it tells us how many of those molecules we have. Now, the sum of the average atomic mass for all of the atoms in the formula will give us the formula mass. And so, for example, if we have H2O, you can see that hydrogen has a mass of 1.008, and then oxygen has a mass of 15.999. If we add those together, we will get the mass of H2O. Except we need to remember that we have to multiply the hydrogen by 2 because there's 2 hydrogens. So we take the hydrogen, multiply it by 2, and then add the oxygen, and that's going to give us the mass of the entire water molecule, and that's called the formula mass. This is for an individual molecule or formula unit. Now the units for formula mass are atomic mass units, just like these. So these here are atomic mass units. And so again, when we add up all those numbers, it gives us the mass of that molecule. Now the mass of a mole of a substance is called the molar mass. And this is actually something that we learned before. This number here represents the atomic mass. It also represents the molar mass in grams per mole. It tells us how many grams there are per mole. And when we have a compound and we add up all the masses to get the formula mass, that also is going to be the molar mass. So for example, hydrogen is about 1, oxygen is about 16, so H2O will have a mass, an atomic mass of 18 because we have 2 hydrogens and 1 oxygen. When you add those up, it gives you about 18. And so that means the molar mass for water is 18. So if you have 18 grams of water, you'd have a mole of water. And the units for molar mass are grams per mole. This is nothing new. So essentially, this whole concept here is exactly what we learned before in terms of moles, except we're not dealing with like a single element. We're dealing with multiple elements that are together, and all we do is just add their molar masses. That is going to be the only difference. So go ahead and watch the practice problem videos, and I hope you have a great day.